In this video, we are going to be adding and subtracting radicals. More specifically, we're only going to be adding and subtracting square roots. We're not going to be doing any cube roots or fourth roots. So first, it's important to know that when you're adding and subtracting with radicals, you need to think of them as like terms. That means that you can only add or subtract radicals if their radicands are identical. So remember, the radicand is whatever is underneath the radical. So as long as your radicals match, then you can add the coefficients. So since we have matching radicals, we have the square root of 4 square root of 5 plus 6 square root of 5. Since these square roots of 5 are the same, then we can add the coefficients. So we're going to add 4 plus 6 to get 10, and the square root of 5 stays. So our final answer is just 10 square root of 5. In example 2, again, notice that our radicands are the same. They're both just 2. So since they are the same, that means we can add or subtract the coefficients. So this time we have 5 minus 7, which is negative 2, and the radical is the square root of 2. So that's pretty simple. As long as your radicals match, you can add or subtract the coefficients. You can also do that when you have multiple radicals. It doesn't have to be just 2. So here we have 7 square root of 3 minus 3 square root of 3 plus 5 square root of 3. Since all three of these terms have matching radicals, we can add and subtract their coefficients in order from left to right. So that would be 7 minus 3 plus 5. I'm going to do this in a couple of steps. First, 7 minus 3 is 4 square root of 3. Then we have plus 5 square root of 3. All right, again, we already established that our radicals match, so we are going to add 4 plus 5 to get 9 square root of 3. Now, in example 4, 4 square root of 3 plus 6 square root of 5, notice that this time our radicals do not match. So since these don't match, we cannot add these two radicals together. Now, one tactic that we can use if the radicals don't match is to see if they can be simplified. These two cannot be simplified because 3 can only be broken down into 3 times 1. 5 can only be broken down into 5 times 1, and neither of those are perfect squares. So if the radicals aren't identical, we want to see if they can be simplified. Sometimes they can be. In this example, we have 3 square root of 8 minus 5 square root of 18. Well, 8 and 18 can be simplified. So what we're going to do is we're going to see if we can find factors of each of these that are square roots. So we know that 8 is 4 times 2. And we know that 18, if we're thinking about what's a square root, that is a factor of 18, that would be 9 times 2. So we can rewrite this as 3 square root of 4 square root of 2 minus 5 square root of 9 square root of 2. Now we can simplify those perfect squares that we see. So this would give us 3 times 2 square root of 2, because the square root of 4 is equal to 2. Okay, then we would bring down the minus 5. The square root of 9 is 3, and then bring down the square root of 2. And now we're going to simplify. So we're going to do that multiplication first. So 3 times 2 is 6, and 5 times 3 is 15. So now what we have is 2 identical radicals, and we can combine the coefficients. So this is going to be 6 minus 15, which is negative 9, and they have the common square root of 2. All right, now this one's a little bit more complicated. It's the same process. We're just going to do that step one extra time. So we want to know what are some factors of each of these radicals where one of those factors is a perfect square. So the greatest perfect square that goes into 12 would be 4, so that's 4 times 3. 27, let's see, 9 is a perfect square, and that's 9 times 3 gives us 27. And 48, this one's a little tricky. So 4 goes into 48, but 16 also goes into 48. It's 16 times 3. So we always want to find the greatest perfect square that goes into that number. And now we're just going to rewrite all of these radicals as radicals of each factor. So this is going to be 4, and then square root 4, square root 3, plus 3, square root 9, square root 3, minus 2, square root 16, square root 3. Okay, our next step is to simplify that perfect square. So that's 4, and the square root of 4 is 2, square root of 3. All right, the square root of 9 is 3, square root 3. And the square root of 16 is 4, square root 3. Okay, so again, we want to continue simplifying those coefficients. So 4 times 2 would give us 8 square root 3 plus 9 square root 3 minus 8 square root 3. Now we have matching radicals, and since all of those match, we can combine the coefficients. Okay, so we have 8 plus 9, and 8 plus 9 is 17. So that would be square root 3 minus 8 square root 3. All right, so again, our radicals match. We're going to continue to combine those coefficients. So 17 minus 8. 17 minus 8 is 9. And we have that common square root of 3. So this is the process of simplifying radicals. This is about as complicated as it would get if you are adding and subtracting radicals that do not have the same radicand.